Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoy, a teacher of physics, and we are going to have a physics lesson for learners in senior 2, and we are going to look at the laws of reflection under the main topic reflection of light. So dear learners, for us to understand these laws of reflection, we need to keep in mind what happens when rays fall on a plane surface. So dear learners, if we have a plane surface, if this is our plane surface, this is the plane surface, Now when a ray of light falls on this surface, so the ray will touch the surface at a certain point. And if we have a line which is perpendicular to the reflecting surface, which is called the normal, N. So this ray is going to be reflected from the surface in another direction. So it will be reflected in another direction. And the ray which is reflected away from the plane surface is called the reflected ray, and the ray which falls on the surface is called the incident ray. Then the angle between the incident ray and the normal is called the angle of incidence. We represent it with letter I. Then the angle between the reflected ray and the normal is called the angle of reflection. We represent it with letter R. So dear learners, it is from this point that we are going to state the laws of reflection. Now there are two laws of reflection. We have the first law of reflection, then the second law of reflection. And when we are stating them, we state them in that order. We are going to state the first law, then we come to the second law. So now let's start with the first law. First law. Now, so the first law of reflection states that the incident ray, reflected ray, and the normal, at the point of incidence, all lie on the same plane, Dear learners, this is the first law of reflection. The first law states that the incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. Dear learners, looking at this illustration, the point of incidence is the point where the incident ray touches the reflecting surface, which means the incident ray I, the reflected ray R, and the normal all lie on the same plane. And this same point where the three lines lie is called the point of incidence. That is the point at which the incident ray touches the reflecting surface. Then what does the second law state? Second law. So the second law of reflection states that the angle of incidence, the law states that the angle of incidence, is always equal to the angle of reflection. So this is the second law of reflection. It states that the angle of incidence is always equal to the angle of reflection. Dear learners, when we look at this illustration, we shall find that is I is equals to R, where I is the angle of incidence and R is the angle of reflection. That is from the illustration. So dear learners, these are the two laws of reflection. The first law states that the incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. And I said point of incidence means the point where the incident ray touches the reflecting surface. And the second law states that the angle of incidence is always equal to the angle of reflection. So when you are asked to state the two laws of reflection, dear learners, you have to specify clearly that this is the first law, then this is the second law. After knowing the two laws of reflection, dear learners, let's look at what we call deviation and glancing angle. Deviation and glancing angle. Deviation and glancing angle. So dear learners, what do we understand by deviation and what do we understand by glancing angle? So now we are going to start with the definition of deviation. We say deviation refers to the change in the direction of rays away from its original path. Deviation refers to the change in the direction of rays away from its original path, meaning away from the direction towards which it was moving. So dear learners, how do we demonstrate this? If we have a plane surface, if this is a plane surface, for example a plane mirror, we have a plane surface. Now we said a line which is perpendicular to the reflecting surface is called the normal. So this is a line perpendicular to the reflecting surface and we call it the normal. We represent it with letter N. So dear learners, if a ray of light falls on this surface, if we have a ray of light that falls on this surface, so this is a ray of light falling on the reflecting surface in this direction. So this ray of light is from a distant object or from a certain object. So when this ray touches the reflecting surface, this ray is going to be reflected in this direction. It will be reflected in that direction from the point of incidence. That is the point where the ray touches the reflecting surface. And dear learners, we said that the ray that falls on the surface is called the incident ray. Then the ray that is reflected from the surface is called the reflected ray. And the angle between the incident ray and the normal is called the angle of incidence. Then the angle between the reflected ray and the normal is called the angle of reflection. Now dear learners, this ray was traveling in this direction, but it has been reflected. Had it been that the direction of this ray had not changed, so this ray would be traveling in this direction. It would continue in this path. But due to the reflecting surface, its direction has changed. But if this reflecting surface was not there, this ray would proceed in this direction. Therefore, the angle between this original path and the reflected ray, this angle, we represent with letter D, which is called angle of deviation. Angle of deviation. That is the angle between the original direction of the path, of the ray and the reflected ray. Is called the angle of deviation. Then this displacement from the original path, the displacement from the original path to the reflected ray is what is called the deviation, meaning the change in the direction from its original path. Its original path was in this direction, but now due to reflection it has changed, which means this displacement is what we call the deviation of the ray. Now, dear learners, this is how we represent deviation on a plane surface. And we also said that the angle which is found between the incident ray and the reflecting surface is called the glancing angle. We represent it with letter G. That's why we have deviation and glancing angle. So glancing angle is the angle between the incident ray. It's a glancing angle, which is letter G. So this is the angle between the incident ray, and the reflecting surface. So dear learners, we said deviation is the change in the direction of rays away from its original path. So this is the original path, but when it changes the direction from the original path, that displacement, we call it the deviation, and the angle which is displaced is called the angle of deviation. Then glancing angle is that angle which is found between the incident ray and the reflecting surface. Now, dear learners, we have a formula that will always relate the glancing angle and the deviation, or the angle of deviation. So now, if we call this I, this is I, meaning the incident ray. So it's going to fall on this surface at a certain point. If we note this point to be O, if it falls on this surface O, it is going to be reflected in that direction. Now, if the direction of this ray had not changed, it will be traveling in this direction. So we can also name this path with a certain letter. For example, let's use letter B, just a letter of the alphabet. So this B represents the original path of the ray. So now, dear learners, let's go and look at the formula that will relate the glancing angle and the angle of deviation. Now, from this illustration, we find that angle, we are going to take this angle, dear learners, this angle R, O, and this surface. So this surface, we can name it with letter S to represent the surface. So now we are going to take the angle R, O, S. Angle R, O, S, which is this angle R, is equal to, now when we take ROS, we can see that we are talking about this angle. Angle ROS is this angle. And when we look at this angle, it is the same with this angle. So it is equal to the glancing angle. So this is equals to G, because they are opposite angles. Opposite angles. We have taken the angle ROS, meaning the angle found at O. Dear learners, when we are talking about angle ROS, meaning the angle will be found in the letter which is in the middle. So when we look at this, the letter which is in the middle is O. ROS. So the angle is found at O. And this angle is opposite to that, which is equals to the glancing angle. Then let us also take angle. Let's take this angle SOB. SOB. Angle SOB is equal to, so SOB is the same like this angle. And when we are to look at these two angles, this angle is the same like that angle, because the angle of incidence is always equals to the angle of reflection. So this one is also equals to G, since I is always equals to R. This angle is equals to that angle, which means if these two are the same, which means the angle of incidence is also equals to the angle of reflection. That is from the second law of reflection, which says the angle of incidence is always equal to the angle of reflection. Now, after noting this, now we're going to have deviation D is always equal to the angle ROS plus the angle SOB. That is, deviation is equal to the angle ROS, which is this angle, plus the angle SOB, which is this angle. But we said angle ROS is equal to G. Then angle SOB is also G. So D, which is the deviation, is equal to G plus G, where G is the glancing angle. So when we add when we add the two, we're going to have D equals to 2G. D is equals to 2G, meaning the angle of deviation is twice the glancing angle. Dear learners, let's look at this. If this angle is G, then also this angle is also G, which means when we add G plus G, we get 2G, which means the relationship is that the angle of deviation is twice the glancing angle. So this is a relationship between the angle of deviation and the glancing angle. So dear learners, let's look at an example on how we can determine the angle of deviation from the formula which says D is equals to twice G, meaning the angle of deviation is equals to twice the glancing angle. Let's see how we can apply the formula in determination of the angle of deviation. That is the angle between, that is the angle from which the direction of the ray has been changed. So example, the example says, given that the glancing angle, given that the glancing angle for a ray of light, the glancing angle for a ray of light, given that the glancing angle for a ray of light incident on a plane mirror is 30 degrees. Full stop. Determine the angle of deviation of the mirror. Determine the angle of deviation of the mirror. So dear learners, this is how a question can be asked. Given that the glancing angle for a ray of light incident on a plane mirror is 30 degrees. Determine the angle of deviation of the mirror. So what we are going to do, dear learners, we are going to use the formula which says the angle of deviation D is equals to twice the glancing angle. So we are going to write solution. Then we read through the question and we find out what is given in the question. Now reading through, we shall find that the glancing angle is given to be 30 degrees. So given glancing angle is equal to 30 degrees. 30 degrees. And you are asked to get D, which is the angle of deviation. So dear learners, we are going to use from the formula which says D is equals to 2G, meaning the angle of deviation is going to be twice the glancing angle, and the glancing angle is given to be 30 degrees. You are going to have D equals to 2 times glancing angle, which is 30 degrees. Then when you multiply 2 times 30 degrees, you're going to get 60 degrees. Therefore, the angle of deviation is 60 degrees. So dear learners, this is how we can determine the angle of deviation. You can also be given a question in this form. You may have a question where the glancing angle is not given. You are given the angle of deviation and you will be asked to determine the glancing angle of the mirror. We are just going to use the same formula, but what we have to do is only substitution. So you can be given, let's have another example. The example says a ray of light is deviated. A ray of light is deviated at an angle, is deviated through an angle of 90 degrees from its original direction. From its original direction. From its original direction. From a plane surface. From a plane surface. Full stop. Determine the glancing angle. Determine the glancing angle. So dear learners, this is how you can also be asked. A ray of light is deviated through an angle of 90 degrees from its original direction from a plane surface. You are to determine the glancing angle. So we are going to write solution. Then when we read through the question, let's find out what is given in the question. So reading through, we shall find that the angle of deviation is given to be 90 degrees. Given angle of deviation is equal to 90 degrees, and you are asked to determine the glancing angle. So dear learners, we are still going to use the same formula, which says the angle of deviation is twice the glancing angle, or you say D is equal to 2G. Now from D equals to 2G, but D is given to be 90 degrees. So where there is D, we are going to substitute the value, which is 90 degrees. So you are going to have 90 degrees is equals to 2G, or is twice the glancing angle. Now for us to determine the glancing angle, we are going to divide both sides by 2. This side by 2 by 2. 2 divided by 2, it goes 1. So G, which is the glancing angle, is equal to, dear learners, when you divide 90 by 2, you are going to get 45. So you are going to have 45, and angle is measured in degrees. 45 degrees. So this becomes the glancing angle. So dear learners, what is very important here is to know the formula or the relationship between the angle of deviation and the glancing angle. And the relationship says the glancing angle D is, the angle of deviation D is twice the glancing angle. So dear learners, this is how we can determine the glancing angle or the angle of deviation. So you can be given questions in this form. You can be given questions in this form. So questions, one can be state the laws of reflection. That is question 1. State the laws of reflection. Then question 2 can be define the following terms. Define the following terms. A, deviation. Then B, glancing angle. And a last question can be given in this form. Given that the glancing angle for a ray of light falling on plane surface is 39 degrees. Find the angle of deviation of the surface of the plane surface. So dear learners, you can be asked questions in this way. State the laws of reflection, then define the following terms: deviation, glancing, angle, and you can also be given a question in this way. So dear learners, up to this point, I would like to say thank you for attending the lesson. I hope you enjoyed. I am teacher Akena Patrick Omon, your teacher for physics. Bye bye for now.